Welcome back to Mr. Leek's free science tutorials. Now, the question that I'm going to be talking about in this video is write 3 equations illustrating the 3 types of decay. Now, in other videos, what I've done is I've talked about the different types of decay. We've got alpha, we've got beta, we've got gamma, and neutrons is kind of like a 4th one, right, where neutrons are then given off in some forms of decay. Alpha is a helium nuclei, 4-2, no electrons. Beta is an electron, 0 minus 1, with a little e next to it. Gamma is an electromagnetic wave. So this question is actually asking about 3 equations illustrating the 3 types of decay. Now, these equations are ones that you may well not necessarily need to be able to learn, right? But what you've got to be able to do is you've got to be able to work out the numbers in an exam. And it kind of makes sense. Alpha, right? What you've got is you've got uranium. Uranium is an unstable atom. 238, 92. So it's got 92 protons, right? 92 electrons, right? And then it's got 238, take away 92 for the number of neutrons. When it decays, right, what it does, it gives out a helium nucleus. All right? So it goes from U to TH. Now, if you actually notice that what's happened is that atomic number there has gone down by 2, and they are there. So basically what that means is it's lost 2 protons. The 238 has gone down by 4. That means that the uranium has lost 2 neutrons, 2 protons. And I know it's 2 protons because they're there. And I know it's 2 neutrons because that then contains the neutron number at the top, giving out an alpha particle. Sometimes the way that question might be written, it might have a gap over the top of there. And what you've got to do is you've got to work out exactly what is then given out. You might have a gap or a box put over the top of that. Or it might have the helium nucleus completely and utterly covered over. Right? And then what you can do is you can do 92, take away 90, gives you 2. So the numbers on each side need to then add up. Beta is then, remember, when an electron is then given off. Carbon-14, so it's got 6 protons, 6 electrons, and it's then got 8 neutrons. That then decays, and the actual element again itself changes. But this time what happens is the number of protons goes up. Because basically when this decays, one of the substances in there, one of the atoms in there, it breaks up into 2. It breaks up into a proton, which makes that number go up, and an electron. So the particle that's in there breaks up into a proton, making that increase, and an electron, making that. And again, if you look at the numbers at the top stay the same. 14, because there's a 0 there. 6 is the same as 6 take away 1. So what you can do is you can work out the numbers. So again, what they might do is they might put that over the top and say, what form of radioactive decay is this? And you can see, because it's gone from 6 to 7, it must be beta radiation because there's a -1. Gamma radiation is then the energy one. You've got 99, 43. When this decays, it stays the same. But what it does, it gives out gamma radiation. So there is no physical change, right? But what there is there energy that is lost. So what they could do is they could put something over the top of that, a blank over the top of that, and they could say 99 over 43 TC, what's going to be in that box there? They put in the gamma. You then know that it's going to be exactly the same because that doesn't physically weigh anything. Now, write 3 equations illustrating the 3 types of decay. What I would do is, in your answer, I would write out that and call it alpha. And then explain why it is alpha. And the explanation is because it loses 4, 2 and a helium nucleus. Write out that and call it beta decay. And you know it's beta decay because the proton number, the atomic number, has gone up by 1. Yet the mass number has then stayed the same. Gamma radiation, the 2 elements themselves stay the same, but energy is then given out.